Hi everyone. Today we're going to talk about LENZE's ability to do repeatable coordinated motion using LENZE's new i950 servo drive. First we're going to get started with a short video. Hi everybody, hope you enjoyed the video. We're going to talk about the technical overview of the i950. First we're going to notice the modular design of the i950. Now rated power, we have a wide power range from 3/4 all the way up to 150 horsepower. Now notice the 480 volt model handles the entire range. We also have some 230 volt models. The 3-phase going up to 7.5 horsepower, while the single-phase model goes up to 3 horsepower. We also like the dimensions. If you notice the compact design, this is the single-phase 230 volt model we're showing here. Very compact design by noticing the dimensions on that. Now we're going to look at the functional overview of the i950 servo. For motor control, we have both the open loop, volts per hertz, sensorless vector control, closed loop, with asynchronous and permanent magnet servo motor servo control. Different feedback options, including resolver, sine, cosine, hyperphase. Also, the OCT is our one cable technology. Talk about that a little later. Next, let's talk about the motion functions. For the CIA 402, this would involve a motion controller. Now also we have available different speed control, torque control, electric shaft, and positioning options. Let's talk a little more about that. Now we'd already mentioned the CIA 402 version. We have the motion controller, and actually the intelligence is inside the motion controller itself. Now we also have a version, we have our technology modules that are built into the drive, in which it is totally parameterizable. Oh, that's a word, huh? Basically what you do is you have parameters. You make changes to your parameters, and that's how you commission the drive. Very simple. Now, if you have a little more complex solution, or you want it totally customized to your needs, you can take that same fast module and build other logic around it to really truly make it your product. Also, we have, for safety, we have safe torque on board, and we also offer an extended safety variant as well. Let's look a little deeper into the functions of the i950. Let's talk about our fast modules. These are our application modules that are pre-made and easy to use. These are the different technology applications that we have. The CIA 402 Basic and Advanced for motion control. We have speed control, positioning, electronic gearing, registration, dancer and tension control winding. We also have a flex cam module for camming, such as a rotary knife or flow packing. See some of the industries that we're in: labeling, packaging, some interlogistics or warehousing, printing for see some registration control, some blurry operation. I can't quite make that out. Not sure what that one is. And also maybe slitting, possibly slitter rewinding. Let's take again a look at all the things that the i950 has to offer. For field bus modules, we offer Profinet, EtherCAT, and Ethernet IP. We have the fast application modules for easy programming. We have basic safety of safe torque off, plus also extended safety is available. So if you need to use ProfiSafe or safety over EtherCAT, we have that available also. You have a wide range of feedback modules available. In fact, we've added also an I/O extension module that can be plugged in instead of an encoder. It adds another 5 inputs and 5 outputs. Next, another new thing for LENZE is our OCT, or one cable technology. We offer basic safety of safe torque off with a power range up to 20 horsepower. This using hyperphase DSL as the feedback system. You notice a new, nice, sleek design of this particular motor and cable design. Let's look at the Ethernet ports to the i950. First, on top, in this case here, we're showing Profinet with different modules. So if you have a supervisory PLC with Profinet, this would be your configuration. Now we also, again, offer the same modules in Ethernet IP and EtherCAT. Now, if we have a motion controller that's controlling the i950, we'll be using in the red line there the system bus motion. Again, it'd be EtherCAT is the motion bus. And lastly, the last port on the bottom, that's for programming. So you simply plug in a normal Ethernet connection and program it from your PLC. Here's a nice graphical depiction of the differences between the i950 controller-based motion and drive-based motion. Notice for controller-based motion and drive-based, we're using the same fast technology modules. Those are uniform in both. The differences is, in the controller-based motion, the fast modules are utilized in our PLC motion controller, whereas in the drive-based, the fast modules are utilized inside the drive itself. Let's talk about drive-based motion. Let's look at this section of the machine where drive-based motion can typically be used. Notice that the fast modules that would be used in this section of the machine. Over on the left, we have the control topology. As you can see, we have a PLC. It's a logic controller. Next, we have the i950 servo drives, where the motion and the different fast modules will be in each individual drive. Next, we have controller-based motion. Now we're selecting this section of the machine with the Delta robot, which is commonly controlled by a motion controller. As we look to the control topology, we've noticed we've removed the motion from the drive. We've moved the motion up to the controller. Thus, now we have a motion controller controlling the i950s. And the protocol is what we talked about earlier, the CIA 402. Here are some examples of some typical solutions using LENZE products. What you can see here is to be endless possibilities with all the combinations that are possible. Also, that LENZE offers everything from the cloud down to an end of a gearbox, including HMIs, PLCs, motion controllers, safety PLCs, safety I/O, and regular inverters. But next, let's talk about my favorite trade show demo. This trade show demo utilizes FlexCam fast modules that are working together to produce a truly amazing result of coordinated drive-based motion. The juggler is my favorite demo machine. At a trade show, this machine mesmerizes people as they walk by and they stop at the machine to watch it do its magic. Just about everyone has tried to juggle at some point in their lives, and like myself, never perfected the 3-ball juggle. This machine can juggle flawlessly all day long without dropping a ball. We have had trade show goers juggle alongside the juggler. Some people can juggle in much more fancy style, but no one can juggle as long without dropping a ball as this mechanical marvel. This machine has no sensors. It is running with a basic calculation that if you throw something at a certain angle with a certain velocity, that due to the main force of gravity, you can determine where it will land. Air resistance and windage are so small of forces that they can be ignored. This is LENZE's drive-based technology at its best. Here there are 4 i950 servo drives that are all synchronized with each other. We mentioned a little earlier that we need to throw the ball at a certain velocity and at a certain angle to know exactly where the ball will land. As you see, the 2 axes that are throwing a ball have to be perfectly synchronized to perform that coordinated motion to throw the ball correctly, consistently, all day long. What we are seeing in this video is the result of all 4 axes using the FlexCam fast module being synchronized with each other while stepping through predefined cam tables. Please notice the red Ethernet cables that are plugged into the i950 servos. This is the EtherCAT communication cables that pass information amongst the 4 axes. The juggler machine demonstrates LENZE servo technology to be extremely reliable and repeatable. Also, the juggler is one example of why LENZE's fast modules are proven and dependable.